Hi everyone. In this video, we are going to talk about time complexity. So this is one of the concepts used by computer scientists to measure the efficiency of an algorithm. But this can be used by the software developers also to write code and to make sure that it is an efficient code and it is efficiently using the computing time and the storage. And also in the interviews, if you were given a problem to solve, especially if it is a data structure or algorithm related problem, I'm sure the interviewer would expect you to talk about the time complexity to explain your solution. And most people also think that this is a concept which is more difficult to understand and learn. But in this video, I will try to explain this concept as simple as possible. Let's start. When we say we measure the execution time, the time complexity of a problem statement, we actually don't measure the the raw execution time of the problem. Instead, we have to measure the execution time in relative to the input size. So we don't say, okay, this problem takes 1 second to execute, or this problem takes 10 seconds to execute. No, we don't measure that. Instead, we measure the time complexity in relative to the input size. Now, let's take a simple real world scenario and we will try to understand the concept of time complexity using that. So let's imagine Bob goes to office every day, and one day Bob's manager asked him to get a file from the locker. And there are a lot of lockers available in the office, and Bob doesn't know in which locker the file actually is. So Bob needs to go through each and every locker, and he needs to check whether the file that he's looking for is available in that locker. Now let's try to measure the time complexity for this particular scenario. Okay. Now imagine if Bob has to spend 1 second in each locker. Say Bob has to open the locker, he needs to take the file, and he needs to check whether the file is the one that he is actually looking for, and then he has to close the locker, right? So imagine Bob has to spend 1 second in each locker, just for an example. So if that is the case, if there are 6 lockers available, then it will take 6 seconds to complete the search operation, right? So the more number of lockers we have, the more time it will take for the Bob to complete the operation. But in case if the file is available in the first locker itself, then Bob will immediately grab it and it will only take 1 second to complete the whole search operation. But in the worst case scenario, if the file is in the last locker, then Bob has to go through all the lockers to find out the actual file. And always keep in mind, when you try to calculate the time complexity, you always have to go for the worst case scenario. So in this case, the worst case scenario is Bob has to run through all the lockers. So if there are 6 lockers, then it will take 6 seconds to complete the operation. So in this case, the more number of lockers we have, the more time it will take to complete the search operation. So if you try to draw a graph between the number of lockers and the time taken, then the graph would look something like this. Because the time taken always grow in a linear fashion in relative to the number of lockers, right? So for example, if there are 6 lockers, then you will have 6 seconds to complete the search operation. And imagine if you have 10 lockers, then it will take 10 seconds to complete the search operation. And if you try to variabilize this, if you have n lockers, then it will take n seconds to complete the operation. So the time complexity of this particular scenario is O of n. So this is the big O notation for the time complexity of this particular scenario. Now imagine another scenario. Consider the same scenario but with a little difference. Each locker now have a label attached to it which actually displays the file name of the file that is inside the locker. Now Bob actually knows the file name. Okay, so in this case, he doesn't have to go through each locker to check whether it has the file he is looking for. Instead, he will directly go to the locker because the locker already has the file name attached to it. So he don't have to search any lockers. He will directly go to the locker, open it, and grab the file. So it doesn't matter how many lockers there are, it will always take 1 second to complete the search operation. So if you try to draw a graph between the number of lockers and the time taken, then the graph would look something like this. Right? Because it is always going to be the constant. The time complexity is always going to be constant because it doesn't matter if there are 6 lockers or if there are 1,000 lockers. Bob will directly go to the locker which has the file name attached to it and he will grab the file. And in this case, so again, consider if there are 6 lockers, it will take 1 second to complete the operation, right? And if you have 10 lockers, again, it will take the same 1 second to complete the operation. So if you try to variabilize this, if you have n lockers, again it will take 1 second to complete the operation. It doesn't matter how many lockers you have, it will always take a constant value to complete the operation. So in this case, the time complexity will be O of 1. So we have a constant time complexity in this particular scenario. Now let's take another scenario. Let's assume now Bob wants to find out if the locker has any duplicate files. He wants to check which two lockers have the same file. Okay, he wants to identify which two lockers have the same file. So what Bob going to do is, he's going to open the first locker, he will take the file out, and he will keep that as a reference, and he will go through all the other lockers, and then he will compare this file with the other file. And once that process is done, he will close the first locker, and he will go to the second one, he will take the second file as a reference, and then he will compare that file with all the other files in the locker. And he will do the exact same process for all the 6 lockers. Now imagine what would be the time complexity in this particular case. So if there are 6 lockers here, so he has to take one locker as a reference, and then he has to go through all the other lockers, and he has to continue the same process for all the 6 lockers. So if there are 6 lockers in place, then it will take 6 into 6, 36 seconds to complete the process, right? And if there are 10 lockers, then it will take 10 into 10, 100 seconds to complete the operation. Now if you like to variabilize this, if there are n lockers, then it will take n cross n seconds to complete the operation. Or in other words, you can say it will take n square to complete the operation. So the time complexity for this particular scenario would be O of n square. Now this is how you usually measure the time complexity for a particular scenario. Always keep in mind that when you measure the time complexity, you always have to go for the worst case scenario. Now let's try to understand the time complexity by measuring it for some real programming examples. Here we have few JavaScript examples, and we are going to measure the time complexity for these examples. So let's take the first example. So here we have a simple array, and we need to find whether a particular element is available in that array or not. So how do you usually do that? You need to iterate through the array, go through each and every element, and then compare that element with the input element, right? So the time complexity would be, so if you have 5 items in the array, then you have to do 5 iterations. And if you have 10 items in the array, then you have to do 10 iterations. But also remember, if the element that you are looking for is available in the first index itself, then you may have to return the program immediately, right? That can also happen. But always remember, when you calculate the time complexity, you always have to go for the worst case scenario. So in this case, the number of iterations in the program will increase with the number of input size, right? So in case if there are 5, then you need to have 5 iterations, and if the array size is 10, then you need to have 10 iterations. So the time complexity of this scenario will be O of n. And let's take another example. This is also something similar, but the only difference is, instead of using a JavaScript array to keep all the items in the list, we are going to use JavaScript object notation. So each and every item in the list will have a key attached to it, which defines what the item is. So we have to find whether a particular item is available in the list, but instead of going through the loop, going through each and every element, and then comparing that element with the input, we are just going to use this index operator to grab the item. So in this case, it doesn't matter whether your list has 10 items, 100 items, or 1 million items. It doesn't matter. You will always need this only one step to grab the item from the list. So in this case, the time complexity is going to be always constant, right? So the time complexity is going to be O of 1. And let's go for the third example. So in this example, we have an array, but in this case, we want to print all the pairs in the array. Let's say if you have an array of 1, 2, 3, 4, and 5, we want to print all the pairs, something like this. Say we want to print like 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. And also we want to print like 2, 1, 2, 2, 2, 3, and so on, right? So we want to print all the pairs in the array. So how do you usually do that? You have to iterate through the array 2 times. So you need to take one item from the array, and then you have to go through all the items in the array and print it. And then you go ahead and take the second item, and again you go through all the items in the array and print it. So if that is the case, if the array has 5 items, then you need 5 into 5, 25 iterations to complete the process. In case if the array has 10 items, then you will need 10 into 10, 100 iterations to complete the process. So in this case, the time complexity is going to be O of n square. So this is how we usually measure the time complexity for the programming examples. And I would highly recommend you to go ahead and try some algorithmic examples and try to find out what the time complexity for each algorithm. Let's say the selection sort will have a different time complexity and binary tree search will have a different time complexity. So I would highly recommend you to go ahead and explore those algorithms and find out what the time complexity of those examples would be. In this video, we actually talked about what is time complexity, and we also talked about the time complexity using some real world scenario, and we also measured the time complexity for some programming examples as well. I hope this video is really useful to you. Thanks a lot for watching.
Audio Jungle.